Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. So in my previous videos, I was actually discussing the 4th chapter of 9th standard science subject, that is structure of the atom. So in our previous chapters, we have learnt about matter and different properties of matter. And we also learned that matter is made up of atoms and molecules, and we also learnt Dalton's atomic theory, and after that we also learnt how electrons and protons were discovered, and also we learnt about J.J. Thomson's atomic model and Rutherford's atomic model in our previous videos. So after Rutherford's model, the next model which we will be learning in this particular chapter is that Bohr's model of an atom. So before going into Bohr's model of atom, you have to understand J.J. Thomson's atomic model and also Rutherford's atomic model. So in Rutherford's atomic model, we learned that the positively charged particles are confined to a very small space inside an atom at the center of atom. So this positively charged particles which are confined to the center of this particular atom is actually known as nucleus. And this particular nucleus contains these particular positively charged particles which are known as protons, and this atom has lot of empty space in it, and there are electrons which are revolving in a circular orbit around this particular nucleus. So this is actually the Rutherford's atomic model which we discussed in our previous video. So coming to the drawbacks of this particular model, here this particular electrons are revolving in a circular orbit. So now electron is negatively charged, and any particle moving in a circular orbit will get accelerated. So if a charged particle gets accelerated, then this particular charged particle will be radiating energy. That means whatever energy that particular particle will be having is emitted out through radiations. That leads to the loss of energy in that particular particle. So here electron is a negatively charged particle. When it moves in a circular orbit, it must accelerate. So when there is acceleration for a charged particle, then it has to radiate its energy. So when a charged particle radiates its energy, electron, which is actually negatively charged, after losing certain amount of energy, it cannot possess the same path. It cannot go in the same circular path. Instead of that, it has to reduce its path to a spiral path. Let's assume that electron has energy E, and with this particular energy, when it traces a circular path around nucleus, then when it completes its full circular path, so part of its energy will be lost through the radiation. Because it is going on losing energy, it cannot trace the same long circular path which it was tracing when it has full energy. So now energy is going on reducing, hence slowly electron should follow a spiral path like this, and the radius of the orbit will go on reducing, and finally at one particular point electron should fall inside nucleus. That means here electron is continuously losing its energy through acceleration because electron is a charged particle. So if electrons falls inside nucleus, then there is only positive charge left in the nucleus. So at that particular time, atoms will not be stable. So this is actually showing that atoms are not stable. So according to Rutherford's atomic model, if we assume that electrons are revolving in a circular orbit, at that particular time they have to follow a spiral path and fall inside nucleus. So if all electrons which are present in the atom fall inside nucleus, then this particular atoms will collapse. So these atoms are not stable. So if atoms are not stable, then matter will also be not stable. But we can see stable matter all around us. So that shows atoms are much more stable. But here, according to Rutherford's atomic model, stability of atom is not explained. So to overcome the drawbacks of Rutherford's atomic model, there was a scientist named Niels Bohr who came up with his own atomic model, where he stated few postulates. So the first postulate of Niels Bohr atomic model was, he came up with an idea of discrete orbits for electrons. So here inside an atom there is only discrete orbits are allowed. So there will be a discrete orbit which is actually defined for electrons, and only in that discrete orbits, only in that allowed orbits, electrons can revolve. So here there are different discrete orbits inside an atom, and these orbits are named as K, L, M, N and so on. Or you can call this as N is equal to 1, 2, 3 like this. So here N represent orbits, discrete orbits inside an atom. So here the first allowed orbit, so let's say this is first orbit around nucleus. So this is the first allowed orbit in which electrons can revolve. So apart from this orbit, the electrons which are revolving in that particular first orbit will not go to other orbits. So here discrete orbits can be known as energy levels of electrons. So here first orbit n is equal to 1 orbit can be known as first allowed orbit or first energy level of electron. So the first orbit n is equal to 1 is the first energy level of an atom, and electrons after filling this particular first energy level only will move to the next energy level. The remaining electrons will move to the next orbit, that is to the L orbit. So this is K and this is L. So in L you have n is equal to 2 level. So this is second energy level. So like this it goes on. N is equal to 3 is there, n is equal to 4 is there. So these are all energy levels of electrons. So the first orbit is known as K and the second orbit is known as L, and it goes on like that. So here the electrons cannot move in all permitted orbits. All electrons cannot move in all permitted orbits. Only when the first energy level is fulfilled, then only the next electrons can occupy the next energy level or the next discrete orbits or the next allowed orbits. So this is actually the first postulate of Bohr's atomic model. So here he came up with an idea about discrete orbits. So here not random circular orbits are present in an atom. There are discrete orbits present in an atom in which electrons are allowed to revolve around nucleus. So coming to the second postulate of Niels Bohr's atomic model, here while an electron which is moving in a particular discrete orbit, it is not accelerated. So electron revolving in a discrete orbit, they do not radiate energy. So when a particular electron is assigned a particular discrete energy level or a discrete orbit, so in that particular discrete orbit, electrons which are moving in that particular discrete orbits will not radiate any kind of energy. So when there is no radiation of any energy from this particular electrons which are revolving around nucleus, at that particular time electrons will not lose any energy, hence the stability of atoms is achieved. So here in first postulate Bohr explained that each and every electron are allowed to move in a particular orbit, a particular allowed orbit which are known as discrete orbits, and electrons which are revolving in this particular discrete orbits will not radiate any kind of energy, hence electrons will be stable in their own energy levels, or electrons will be stable in their own discrete orbits, hence there is no collapse of electrons inside nucleus, and hence the stability of atoms is achieved. So inside an atom, if you consider this as a nucleus, then the first energy level is known as K and the second energy level is known as L, and the third energy level or the third discrete orbit is known as M, and the fourth discrete orbit is known as N, and for higher atomic number elements more orbits will be there. So now these are like n is equal to 1 energy level, and this is n is equal to 2 energy level, this is n is equal to 3 energy level, and this is n is equal to 4 energy level. So all this n, so this particular n represents the energy levels or the discrete orbits of an atom. So in 1932, one particular scientist named Chadwick, through his experimental observation, he proved that there are neutral subatomic particles as well in the nucleus of the atom. So in the nucleus, not only protons are there, so along with protons, there are another subatomic particles present inside the nucleus of an atom. So these particular subatomic particles are electrically neutral. They don't have any kind of positive charge or they don't have any kind of negative charge. So these subatomic particles were later on named as neutrons. So a nucleus of an atom contains both neutrons and protons, and the charge of nucleus is positive because positively charged protons will be there inside that particular nucleus. Along with that protons, there are few more subatomic particles present with protons inside nucleus. They are electrically neutral. They don't have any positive or negative charge, and the mass of an atom is decided by the mass of number of protons and the mass of number of neutrons present in that particular atom. And when you compare mass of proton, so let's say MP as mass of proton and Mn as mass of neutron. So mass of proton is comparable with the mass of neutron. So neutron is slightly heavier than proton. So the mass of neutron is slightly greater than mass of proton, which can almost considered as they have equal mass. When the mass of proton is compared with the mass of electron, then the mass of electron is 2000 times lesser than the mass of proton. But when we compare mass of proton with mass of neutron, they are almost comparable with each other. So the total mass of an atom, is the sum of mass of the protons present in that particular atom and the mass of neutrons present in that particular atom. So total mass of an atom is equal to mass of all protons plus mass of all neutrons. Why we are not considering mass of electrons is that electron mass is very less compared to the mass of protons and neutrons. So that's why mass of electrons are just ignored and only mass of protons and mass of neutrons is considered for the total atomic mass of an atom. So that's why atomic mass number is basically the number of protons present and the number of neutrons present. So we'll come to that particular concept as well. So this is all there in this particular video. Further concepts which are there in this particular chapter will be discussed in subsequent videos. So if you want to learn physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.